So now we go from the profound to the creepy. Imagine, if you will, a glacier. One of those vast mountains of ice that hang off of mountains or of coastlines. When you read about glaciers, they tell you that every year glaciers move. I mean, they don't sprint exactly. They just creep along at a rate of, well, we did look it up. And if this block of ice right here were a typical glacier, it would move about 10 inches every day. So if I'm standing, as I am right now, 20 inches from, let's make this an incoming glacier, in 2 days it would move from where it is now to here. So that's an average glacial speed. It's less than 1 foot every day. Now, here's the puzzle. We're going to take you to a real glacier. It's a big one that for some reason, says our correspondent Peter Standring, is behaving very badly.
Take a look around. This is Greenland's largest glacier, the Jakobshavn. It's more than 4 miles wide and over 1,000 feet thick. It looks solid and indestructible, but looks can be deceiving. Like any glacier, the Jakobshavn is actually a river of ice. It's moving. Fed by the massive Greenland ice sheet, it's now the fastest moving glacier in the world. Jay Zwally, a glaciologist from NASA, knows exactly how fast the ice is moving.
So right now this ice is moving. You can't feel it moving. It's moving this far in 1 day. In a month, it'll be 5 feet past that pole over there.
Instead of moving 1 foot a day, which is normal for glaciers, in the last 5 years, the speed of the Jakobshavn has increased to an astounding 113 feet every day. And no one knows why. It's a mystery buried deep within the Arctic ice. Here you can see the consequence of all that speeding up, where the glacier meets the sea and enormous icebergs break off. This glacier is not just speeding up, it's shrinking 8 miles in just the last 5 years as huge pieces of ice fall into the ocean.
To give you a better idea of just how much ice, take a look at this iceberg here. We're estimating it to be about 50 feet high. In terms of thickness, that's how much ice the Jakobshavn Glacier is losing each year.
The result is that this glacier alone is responsible for 4% of all sea level rise worldwide. So, why is this happening? At this research station set up on the Greenland ice sheet, scientists use a variety of tools to answer that question.
Hello there. How are we doing?
Good.
We keeping warm?
Yes.
See you.
Conrad Steffen is the camp's founder. He's spent the last 31 winters out on the Arctic ice.
And you guys manage to go about your business and your experiments without freezing to death out here?
Oh, I have never lost a grad student here on the ice.
About 10 miles from camp is this GPS receiver, which gives precise measurements of the position of the ice. This allows scientists to track changes in its speed and when they happen.
It's always exciting to take a look and turn the unit on and see what it's recorded throughout the year.
Around the clock, weather stations measure the height of the snowpack, the wind speed, humidity, and temperature. These instruments collect volumes of information, and here's where they put it all together. These red tents serve as both kitchen and laboratory.
Good morning. Good morning. I heard you have Starbucks here.
A warm place to ponder the mystery of what's happening to the Jakobshavn Glacier.
That's minus 5.8.
And is that Fahrenheit or Celsius?
That's all in Celsius. We
Okay.
measure everything in Celsius.
Connie Steffen says that the main culprit is rising temperatures.
The summer temperature have increased by about 1.5 to 2 degrees over the 15 years, but the winter temperature have increased by 6 degrees.
That temperature increase has led to a longer melt period, more days each year when the ice melts rather than freezes. Aerial and satellite observations show that the melt water, that blue area on the ice, doesn't stay on the surface. So, where does it go?
I know it's hard to imagine, but I'm actually standing at the bottom of a big lake. It measures 3 miles by 3 miles. By the end of July, enough of this ice and snow will have melted to fill this lake with 60 feet of water. Eventually, all of that water finds a hole and makes its way down to the bottom of the ice sheet.
Glaciologists thought that water would freeze before it ever made its way down through 4,000 feet of ice. And normally it would, if it weren't for one thing: the incredible pressure caused by the huge volume of increased meltwater on the surface forces it to the bottom by sheer weight.
What people didn't know before was where that water went. They thought maybe it stayed in the glacier, thought maybe it went to the bottom, stayed in a tunnel. But our results show that it goes to the bottom and spreads out, actually lifts the glacier up a little bit and allows it to float partly on a bed of water,
literally sliding it into the sea. And although this effect takes place mostly in the summer, recent satellite measurements show that even in the sub-zero Arctic winter, when there is no melt effect, the Jakobshavn is showing little signs of slowing down. Jay Zwally places the blame for this on global warming.
The really disturbing thing is the pace of things that have been happening in the last 10 years. Almost all the scientists in the world, all the respectable scientists, believe that man is having a definite impact. And we're seeing this more in the Arctic than anywhere else.
Just as unsettling is data from some of Greenland's other glaciers that show that they too are starting to undergo the same dramatic changes. Where and when, or even if this will stop, no one knows. But what scientists do know is that changes they once thought occurred over hundreds or thousands of years are today taking place right in front of their eyes.